So this video is the follow-up to the other video lesson I made, which was covering how to write half equations in acidic conditions. So today we're going to go through how to write half equations in alkaline conditions. So I will say at this point, if you've not watched the one on acidic conditions, then please go back and view that video, because I run through the steps of how I build half equations around the information that is supplied to me in the question. So A is show the conversion of iodide into IO minus in alkaline conditions. So just like I said in the previous video, what I like to do is leave a gap either side of the reactant and product so that I have space to put in whatever I need to put in, which could be H plus, water, or an electron, or in this case hydroxide. And then the first thing you have to do is assign redox numbers to determine whether the species has been oxidized, reduced, or is unchanged, and it's just a conversion. Iodide is -1. It's got a 1 minus charge. And then on the right hand side, oxygen is always -2. So for this IO minus to come to -1 overall, that means the iodide must be +1. So we can see that the iodide has been oxidized. So the electrons will go on the right hand side. Then on the left hand side, I need to introduce the condition, which is alkaline, so that involves hydroxide. And then finally, you will see that I now have hydrogen and oxygen on the left hand side, but only oxygen on the right hand side, which means I have to add water to the right hand side. So now that we have everything in, the next thing to do is balance the atoms, and then the charges last. First thing I'm going to do is place a 2 in front of the hydroxide. The reason why is because I can see 2 hydrogens on the right hand side, and so now putting that 2 on the left gives 2 hydrogens. And also there's also 2 oxygens on the right hand side, and now there's 2 on the left. So the oxygens are balanced, the hydrogens are balanced, and the iodine as well, because there's 1 on the left and on the right. So finally now is to balance the charges. So I'm just going to get rid of those redox numbers. So on the left hand side, the total charge is -1 plus 2 times -1 is -2, comes to -3 overall. That means the right hand side must also come to -3. So to achieve that, all I need to do is place a 2 in front of the electron. So now we have -1 on the IO minus plus 2 electrons gives -3. So the equation is both atom balanced and charge balanced. Next one, B. Mn2 plus, leave a gap either side, into manganese dioxide, and assign the redox numbers. And again, I can see this happens to be another oxidation. On the left hand side, I introduce the condition again, which is hydroxide. And then I again have the situation where I need to put a water on the right hand side. Right, finally, we need to balance. Atom balanced and charge balanced. That's it.